Oh, we got lucky then. What are the odds? Yeah. Okay. It's time for my weekly making fun of Keely for not having any dressing. So, do you feel made fun of?
No.
Oh, dang it. Well, anyway, good job being healthy. Weird, huh? Can I sit here? Okay. All right. So today, you're sort of chatty, but it's okay. You're just excited to learn this. I understand. All right. Or it's game day. Don't, I better go left arm. Game day. I just looked up Highland's roster because it scares me, but there's only like one or two hard names on there. Highland. We
have only scouted Murray. We have not even.
Yeah, I haven't looked at Murray's yet. In all my career, usually not Murray, East and Highland, they have the hardest names to announce. Okay, molarity. Yeah, sorry. Solution stoichiometry.
I did not even think about that.
Yep. Hey, anyone willing to admit they actually read the book?
No.
One person, and she's the student teacher. This is pretty much the exact same textbook they have at Utah State and BYU.
Not pretty much, like literally the exact same.
It's just not paper. That's all.
Yeah.
So most of you will take chemistry something in college, even if you pass the AP test. It will be the same textbook, most likely. Weber State uses a different one, but whatever. All right. The objectives today is to be able to do solution stoichiometry problems. When we are at solution stoichiometry, that means we are within like T minus 3 or 4 school days till the test. Could be Friday, could be Monday, could be Tuesday, could be tomorrow if I feel like it. It won't be. Come on, people. Homework. These are not graded, but it would help you greatly if you watch the 3 ed puzzles on stoichiometry. There were 5 of them in this unit. The first 2 are on your grade. I graded more of those today, but I haven't synced to the grade book. That will happen during 5th hour. So if you're like, wait, he corrected, but my grade didn't change, like that'll get adjusted. All right, here we go. So the first thing before you can do this stuff, we need to talk about molarity. So molarity, we're going to use it the rest of the year. If you had chemistry before, hopefully molarity sounds familiar. The kids just tested on it today and loved every single part of it. The unit for molarity is a capital M. So you'll see like, oh, it's 4 molar. That means the molarity of the solution I'm describing is 4. Now, what big M really means, it's a unit that compares the moles to the liters. So I should be more technical here. Moles of solute over liters of solution. Hold on. Okay, so the units are moles per liter. All right, hey, I think I've said that before. Let's just get rid of all this trash. It is pretty familiar. Okay. All right, so to find molarity, oftentimes it's given in grams, but was grams in the unit for molarity? No. So it'll say something like you have 100 grams of LiF in 2 liters of solution. Thank you.
You're welcome. They're not alphabetized.
How dare they?
Why not on Mumford? It wasn't my fault.
They're alphabetized by AP Chemistry. Okay, I don't really know what this is for. Okay, I feel good about that. Next, so to find molarity, we would need to know the moles over the volume, right? So it gives me the volume is 2 liters, but it doesn't give me moles. It gave me grams. Nope. Because it says in 2 liters of solution. Addie, because that would be easy. And easy science is called biology, remember? Okay, moving on. So how do I find moles? Anyone remember? This is hurting my feelings. Yeah. By molar mass. So you take your given, which is 100 grams, and you divide it by your molar mass, which is 26. 100 over 26 is basically 0.4. You okay with that? Not 4, 0.25. No, it is 4. I'm an idiot. It's roughly 4. I'm sorry, I'm an idiot. It's around 2 molar. If you don't trust me, type it in and see how it works out. Seth, yes. It's okay. Lithium fluoride. So this was 7 and this was 19. Seth, there's no way you're the only one that wondered that, so don't feel dumb. There you go.
That's the best word, David.
Okay. Now, here's something interesting for you guys. AP chemistry, we never really do this. In normal chemistry, we do it a ton. But very rarely do I give you grams and ask for molarity. But extremely common, I give you molarity and I want to know the moles. So if I have let's say I have 50 milliliters of a 1.5 molar solution of LiF, that's lithium fluoride, not life. I don't know if there'd be a comma there, but we'll pretend there is one. How many moles are present? Say this you have to do over and over and over and over for the next week of math. You must be able to go from a volume and a molarity to moles. It will become very second nature to you. And it's not bad. Okay, does anyone remember what molarity really is? The unit? It's moles per liter. You okay with that? All right, do you notice that this says liters? Do you notice this says milliliters? Oh boy. So anytime I give you milliliters, you need to do what? Divide it by 1,000. So 50 milliliters is really 0.05 liters. Okay, what do I want to solve for? Moles. So what do I need to get rid of? Liters. What does this tell me? It's 1.5 moles for every 1 liter. So I take my volume and I multiply it by my molarity. So we got 1/20th of 0.15. I don't know what that is. 0.075. You okay with that? Okay, we can summarize this process here. To find moles, from volume and molarity, multiply the volume, and I'm going to say liters, by the moles.
We just do a little circle thing.
Do you feel like it? All right. So this isn't the worst. Remember in limiting reactant problem, I heard that. I heard that hurt. Okay, just it hurt. In limiting reactant problems, we had to get everything to moles. And we did that. We took the molar mass, or sorry, the given and divided by the molar mass. Sound familiar? All right. In solution stoichiometry, we don't do that. We do this. Yes, ma'am. Okay. Where we'll say that louder while you're looking at me. Oh, yeah, it is. Thank you for speaking for Preston. I drove with him once in the driver's ed car before my wife got me quarantined, and he didn't talk much. The other driver would be like, Preston wants to know. Thank you, though. That's very important because that was definitely wrong. So to find moles from volume and molarity, multiply the volume in liters by the molarity. Easy enough. Let's do some practice. So I'll give you 3 problems, number 1, number 2, and number 3. So all these, I want to know the moles. So, all right, well, whatever. So I have 25 milliliters of 0.8 molar. I have 750 milliliters of 5 molar. I have 1.6 liters of 0.25 molar. So see if you can figure out the moles for each one of these and then tell your lab partner. Well, hello, Mr. Cephalo.
Did he come talk to you
Like lately?
today?
No, definitely not.
Okay, so he wants to get in your online driver's ed. He took it
Okay.
like 2 years ago.
Sweet.
So, but
How old is he?
he's a senior.
Okay.
He's already, so this is when he paid.
Okay.
So I just wanted to give that to you, so you had it, because
Okay.
according to the record I had, it wasn't. We didn't go back. No,
Far
we went back
enough.
2 years. So
Okay.
anyway, he should
Sounds
be
good.
coming to get you. He's a wrestler, so he.
Okay.
Anyway.
Sounds good.
settling for your-
Thank you.
Thanks.
Is it 0.02? Yeah. 4.25? 3.75. You're good. I'm trying to do them in my head. 0.4. I was wrong on this one though. I'm pretty good at head math, but I put 4.25 on this one because I went up a quarter above 4 instead of down a quarter before 4. And I don't know if that made any sense, but like I was closer than it looked. All right, here we go. How many of you had 0.02, 3.75, and 0.4? Okay. We feel all right about this? I feel great about it, so hopefully you do too. Okay. Next, we're going to pause, and hopefully you've watched the little video. Excuse me, the little video that, at least the first one, where I have you draw a beaker. Who's done that one? Where you draw the picture. Okay. Understanding what's going on inside the beaker makes the math a lot easier. So if you haven't watched it, you should watch it because I'm not going to do the most thorough job teaching it because I have given you a week's notice that I wanted you to watch this thing. First of the 3. Okay. So the first of the 3 is we are going to mix. This is not math yet, but understanding this will help you. We are going to mix 2 aqueous solutions, but they're going to form a precipitate. So the picture would be a beaker, the universal sign for it having liquid in it, and then some precipitate. Are you okay with that? All right. This will be the precipitate. Now, without even needing to know much more, what would be in the liquid right now? All right, the spectator ions would be flying around. Now, there's no guarantee that there's a minus and a plus, because whatever, like the spectators, if it came from a solid or whatever. Okay, now, there's one other main component. Anyone remember? Ryan?
So the ion that's in the precipitate, but it's in the excess.
All right,
reaction.
I'm going to say the excess ion now. All right, the excess ion. Okay, the ion in the precipitate, which I'm just going to say is PPT. Are you okay with that? And excess reactant. Let's see, whatever, reactant. So those are the things that are in the beaker once the reaction has happened. Now, we have to account for the math. So what I want to know in these problems is I want to know the mass. Let's put it up here. So the mass of precipitate. That's the solid that's formed at the bottom. We did the reaction where we spun it. We've done it twice. The precipitate, the one in the centrifuge that forced all the precipitate down. We got rid of all the spectator crap. All right, that has mass. The yellow thing you collected the other day, it had mass, right? The lead 2 iodide. Okay, so we want to know the mass of the precipitate in these problems. Then I want to know the concentration of my spectator ions. Then I want to know the concentration of my excess ion. Now I'm going to put like another plus or minus right here. The charges don't matter at all. I'm just trying to show that they're ions. You okay with that? Okay. The test will also ask you to identify the limiting reactant. That's not like a number. You just want to know what the limiting reactant is. Okay. Now, have I even, looking up here, is this confusing? Have I talked about brackets yet? Okay, that line sucked, but whatever. Brackets are shorthand for the word concentration. Because no one wants to write concentration, right? Nobody. All right. I went on a mission and I lived in Charlottesville, Virginia. CHARLOTTESVILLEVIRGINIA. I was not going to write that on every letter because we used to like write stuff. So it was CHA.VA. That was what was Charlottesville, Virginia, in that town. Because no one, like that would have been my entire Monday. Like, and that was Charlottesville. Okay. Anyway, brackets. I wish we had that. Like Tom. Oh, he lives in Charlottesville. Okay, that would have been sweet, but whatever. If you ever get to go there, by the way, most beautiful place on the planet Earth. Okay, so concentration. If I say bracket SI, that means the concentration of the spectator ion, and we're going to measure that in molarity. So tell your partner, in order to know the molarity, what two values do you need to know? Okay, the moles and the volume. Okay, the moles and the volume. a lot of kids will do everything right. And if you watch my video, I think I warned you. And then they divide by the wrong volume. Does that sound familiar? You should divide by the total volume at the end, because these are two solutions. That means it's like pouring a little bit of liquid in A and then in B, and the volume goes up, right? Okay. So can someone tell me, actually, screw that. Tell your partners. That's probably not appropriate. I apologize. All right. My videos are averaging 0 views, so who cares? All right. Tell your partner chemistry-wise, what's happening with the spectator ions? Okay, so that was not a hard question, hopefully. Rhymes with muffin. Nothing. So listen, stick with me. Chemically, nothing really happens with the spectators, right? This is important. Chemically, nothing really happens with the spectators. Mathematically, is there something that happens to the spectators? Molarity. Yes, that gets kids. Why, brain-wise, why is the molarity changing if nothing changed? Because the volume changed. So if you had whatever NO3, but then, and you had its concentration, but then you raised the amount of liquid, the concentration had to have gone down. Okay, so all these things are like the chemistry and the thinking that will apply to the math as we go along. Okay, so let's add more to this picture. So give me your favorite reagent we've used that's aqueous but will form a precipitate. AU, thank you. AU what? NO3. All right, that's aqueous. Tell your partner why. Because nitrate, you can't date that girl. She'll never. She likes being alone. All right, so now this would really be AuNO3 or whatever, but just for right now, uh-oh, is that you, Aisley? It's okay. It's a good life. Okay, for just a minute, I'm just going to ignore that it's a 3-to-1. Are you okay with that? I'm just going to say it's 1-to-1. Okay, plus I'm going to add what? Give me something that's aqueous that gold will hang out with. I is fine. Thank you. Mercury. Well, I don't want to do mercury actually, because so lithium iodide, since you said I don't know, but now you do. Okay. Is this soluble? Like, is it aqueous? Yeah, because family 1 metals don't form precipitates. Family 1 metals don't form precipitates. Okay, but now I've poured them together. I've added them together. So I got a clump right here. Will you label the clump? Like its identity. What chemical is that clump? Okay, check with your partner. No. Okay, we'll get there. Okay, I got a bunch of I don't knows, and that's fair. But here's Aisley. Is it? Okay, here's NO3. Clearly, those boys have tried and she shot them down. All right. NO3 does not form a precipitate, and neither does lithium. So NO3 and lithium must be the what's? Spectators. So what must be hanging out? Gold and iodine.
I saw that in my head.
It is. What?
I saw it in my head.
Okay, good. Okay, so my precipitate, don't talk right now. My precipitate is AUI. Are you okay with that? If you ever draw something with NO3 in here, I'm gonna talk to your counselor and they'll take you back to like your 3rd grade year. I'll be so livid. Because NO3 never makes a precipitate. It's always a what? A spectator ion. No. So we'd have NO3 in here somewhere, right? Just chilling on its own. And what else? Lithium. Okay, well, we'll just make it up. This would be off the charts expensive. So let's say this is my limiting reactant, and this would be my excess reactant. So write whatever's left in the solution. Write whatever's left in the solution. No, anyone else look at that and think it's just says liar? Okay, so check with your partner, see if you agree the same thing that's still in solution. All right, so all in favor say aye. Aye. Okay. I minus. So make a note. Make a note. If it's in the excess reactant and the precipitate, then there is still a little bit of it left in the solution, and you have to account for it. You have to account for it. So everything I would want to know, I would want to know the mass of gold iodide. Now, we didn't include the subscripts for right now because I didn't want to complicate it too hard. We'll get there. But I'd want to know the mass of that. I would want to know the concentration of NO3, Li, and I minus. Fair enough? Okay, who's with me right now? Okay, let's talk real quick about one last thing before we do math. I should have done this with molarity. I just remembered as I was talking about this. So AuNO3 would most likely have a 3. Okay, why? Because gold is usually a +3 in most compounds. It's not always. You would only really know what it was because I would tell you the name. I'd say gold 3 nitrate. You're like, oh, that means gold is a 3. Now, what it doesn't mean, we're better than this. Look at me. Gold 3 nitrate doesn't mean there's 3 golds. It means there's 3 things with gold. Okay, that's a long time ago, but here we go. If I have the following, if I have 1 liter of 1 molar, pretty hard math here, welcome. 1 liter of 1 molar gold 3 nitrate. I want to know the moles of AuNO3 3, but I also want to know the moles of Au plus 3, and I want to know the moles of NO3 minus. Crap nuggets? Is that what you said? No? Yeah. Oh. I have good news for all of you. I'm getting my shoulder looked at tomorrow. So he can tell me that it's destroyed and needs surgery. I won't leave, but I may come back at some point in the year like this for 8 weeks and have to write left-handed. I can't even like turn my doorknob and open it right now. It's not good.
That sounds exciting.
Well, it's just time. I'm old. I lifted my mug up. The last time I heard it, it's conference. That's why. I was laying on the couch watching some TV, mostly asleep, and a fly was bugging me. I'm like, I wanted to relax. And so it landed like right there. I'm like, okay. And I like tried to get the anyway, and I hit the couch and it just, I about died. I started screaming. My whole family, they're like, what just happened? Because I'm like, I tried to kill a fly. Who doesn't get hurt doing that? Okay, do we have an answer? Okay, I know you two do. You're supposed to get an answer. It shouldn't take more than 10 seconds. It was a good story, but you had 10 seconds before the story. Okay, here we go. Can someone answer me this? I want other people to answer. Thank you, though, Corbin. All right. Danielle, can you answer this question? What is 1 times 1? 1. She wasn't even here, and she can do this math. 1. 1 liter of 1 molar, you would multiply them, right? And it's 1. All right. How about AU plus 3 then? 1. And NO3. 3. 3. 3. Does the O mean you got it? Okay. Look right here. Please. This is in the video that half of you have ignored. That 3, look at me. This 3 means for every 1 AuNO3, there are 3 NO3s. Right? How many AUs? 1. Now, I'm not going to break the N's and the O's down. We would never say 9 O's because it's an ion of NO3. But make sure if there's a subscript, you realize, well, there's a lot of stuff in there. It's 3 times whatever the overall molarity is. Okay. Do you want another one or you're okay with that? You want another one? Okay. I'm just going to keep it at 1 so it's easy. You okay with that? So I'm going to say I have Mg and PO4, which would really be Mg3 PO4 2. So I want to know the moles of all of that. Why did I do this to myself? I want to know the moles of Mg. I want to know the moles of PO4 minus 3. Take just like a minute maximum. Oh yeah, sorry. The molarity, it was 1 liter of 1 molar. Just so you can do the math without typing. It's 1 molar. 1 molarity is fine. It just sounds weird. All right. Oh, never mind. It doesn't. You don't even know what I was thinking. You never will. Okay. Tell your partner right now, not me. Tell your partner, how many moles of Mg3 PO42 are there? 1. Awesome job. Okay. How many moles of Mg are there then? 3. How many moles of PO4? 2. Are we okay with these ideas? Awesome. Okay. I think that we're ready. Okay. So all of this has been some chemistry background to help us with the math in the future. So solutions, stoichiometry. Bless you, child. Number 1, weird. Balance the reaction. We've been through this a lot. Number 2, determine the precipitate using solubility rules. Ruh-roh. A lot of you in that one video, you're like, I think I understand everything except for why something stays together and why something falls apart. Hashtag one of the triplets this morning. I read that. Right? This one was the second of the first two, not any of the bottom three. It was how to know whether something stays together or falls apart. Okay, next. No, you will have that chart. I've been doing it without it to try and encourage like you to think more about it so that when you have it, it's a piece of cake. Okay, number 3, find the limiting reactant by looking at moles given or by using both given moles to solve for grams of the precipitate. Okay, so this is nothing new here, except for we find moles from molarity this time instead of moles from grams. Okay. Number 4, find grams of precipitate. You should probably maybe put by using the limiting reactant. Like you probably know that, but you may not. So like the limiting reactant will tell me how many grams I can form, right? Yep, this is all the same, except for instead of grams, I'm giving you a volume and a concentration. And instead of ending for grams of all of them, I'm asking for their concentration. All right, find concentration of each ion by doing the following. The concentration of the ion in both the limiting reactant and the precipitate is 0 grams. Will you explain that to your lab partner? How on earth is that 0? They're still there. Oh, sorry, this should be a molar. That should be molar. Molar. What an idiot. So the concentration of those is 0. You know why? Okay, are we ready? That was the quietest conversation ever because you're still writing down the rules. The answer was, if it's in the precipitate, it's not actually in the solution. It's in the solid at the bottom. Uh-oh. And then if it's in the limiting reactant, it also means it's completely consumed. So all of it is taken from the solution and attached to the precipitate, which falls out at the bottom. All right, part B, the concentration of the spectator ions is equal to their initial moles divided by the new total volume. Their initial moles is just their volume times their concentration. All right, part C. The ion in the precipitate and excess reactant is equal to the initial moles minus the used moles divided by the total volume. Yeah, that's a minus. We've done this part many times. We just never usually divided it by the volume. But we do that because we want the concentration. Okay, I have a practice problem right here. No, I guess I'll just leave that. You've probably at least written out number 1. Okay. So we have 300 milliliters of 2 molar magnesium chloride. I'm going to put the equation right here. So magnesium chloride is MgCl2, and it is aqueous. it is added to 500 milliliters of 3 molar silver nitrate. Silver nitrate, AgNO3. And then my arrow. All right, so let's see, I don't know, 10 seconds. Tell your partner, I'm praying here. Tell your partner what the precipitate's formula will be. AgCl. Did you know that or did you hear Beal? Okay, nice job. There you go, because NO3 won't. All right. So AgCl, thank you for not saying AgCl2. If you did, you're still a good human, but it is just AgCl. That's my solid. Plus my spectator ions are NO3 minus and Mg plus 2, right? Oh, wow, good or oh, wow, bad? An oh, wow.
Yeah, well,
Okay.
I didn't think that you could write them apart like that.
Yeah.
But it makes sense.
Okay.
Did you put a 2 in front of the NLP?
Yeah, you would actually put a 2 right here. Well done, lab partner. Okay,
She's smart.
so yeah, ain't no doubt about that. So we have determined the precipitate right here, right? We have balanced it. That was number 1. I guess I didn't really balance it, but there would have been a 2 over here, a 2 over here, right? Okay. And then number 3, find limiting reactant by looking at the moles given or by using both given moles to solve for grams. Okay, my friends, I like to do things that take less time. Are we okay with that? In this reaction, really, I had 2Cl minus plus an Ag plus made, sorry, it has to be a 2 here, 2 AgCl solid. Now, Jackson is like, what? Why would I waste my time doing that? Right? Just say yes. If they're all 2s, you might as well say what? Math-wise, they're all 1s. Are you okay with that? But technically, they all were 2s, but math-wise, don't do everything and divide it in half each time or multiply it by 2. Just make them all 1s. Are we ready? Okay, so what I need to do is I need to take my problem and I need to find the moles. I'll come back up here. We might run out of time today, but we'll be okay. I want to know the moles at the start. These will not take very long once we get good at them. All right, so the moles at the start of Mg Cl minus, Ag plus, and NO3 minus. I want to know the moles at the start of that stuff. So this is 0.3 liters, right? So magnesium, it would be equal to 0.6 molar. Raise your hands if you know where I got 0.6 molar. That's a really small amount of hands, and that's okay. You take the volume in liters, which was 0.3, and multiply it by the molarity. And as long as magnesium just has a 1, then it's equal to that number. That means chlorine is actually what? 1.2 molar. Why is that doubled? Good, because for every 1 MgCl2, there are 2 chlorines. Okay, then this one's easier because there's no subscripts. There's 1 and 1. So I have 0.5 liters times 3 is 0.15 molar. Or sorry, 1.5, thank you. Okay, so let me, you're onto it. Let me write the net ionic again. I have Ag plus Cl minus goes to AgCl solid. That's the net ionic, right? All of these, they were 2s, but we reduced them to 1. When they're ones, it's easy. For silver, I have 1.5 moles. For chlorine, I have 1.2 moles. So which one is the limiting reactant? I took 3 or point, yeah, I took 3, sorry. And I multiplied it by 0.5. Okay, you're welcome. Okay, so this is pretty simple, right? Which one is my limiting? Chlorine is my limiting, which means silver is my excess, right? Are you okay with this? Okay, now this one's easy because it's ones. I'm aware of that. But now this is pretty cool. Just from this, I could actually tell how much AgCl is made. Anyone know what it is? 1.2 moles. Why is it 1.2? It's equal, since they're ones, it's equal to whatever the limiting reactant was. You didn't hear that. Someone just yelled, someone sucks. Okay, now I'm looking pretty good right here. Can anyone tell me what my excess of silver is? It's 0.3 because it's the difference between these two, right? I'm going to get rid of this one. And this is what I have now. Okay, this is gone because it's my limiting reactant, right? So to find the mass of silver chloride, I take 1.2 moles and I multiply it by its molar mass. 1 mole is, I should have this memorized, I use it all the time, but I don't. 143. 143 grams. Someone type that for me. What's that? That tells me the mass of my precipitate. So far, sort of okay. I know this is tricky. And about like 90% of you are like, what in the world is he doing? He's just pulling numbers out of his butt. I'm not. Okay. Can someone tell me the concentration of Cl minus? 0. Because it's in the precipitate and the limiting reactant. Can someone tell me the concentration of Ag plus? I don't know. It's 0.3 divided by the total volume, which was 0.8. 375. Okay. Now, listen, I know a lot of you are like, whoa, what? We're going to do it all tomorrow. Oh, crap. The spectator ions are just what they were divided by the new volume. All right. Have a great day. I needed like 5 more minutes.